Hello, everybody. Welcome to the Career Forum in Design and Applications Engineering for Additive Manufacturing. I'm John Barnes. I am the Vice Chair of SME's AM Technical Community, and we put on this forum as well as we do several throughout the year. This is one of them. We will probably have a live one at Rapid, which is coming up September 13th through 15th in Chicago. We'll have a few housekeeping notes here, and then you'll see me again. From that, Susie, I'll let you go through our housekeeping agenda.
Thanks, John. Before we get started with formal presentations from our panelists, let me cover a few housekeeping items. First, make sure that you submit any questions, comments, and/or insights to our panel by using the Q&A box. Note that your microphones are automatically muted, and if you have questions or comments, again, please use the Q&A feature. We will be monitoring this feature and try to address all of your questions and comments. Second, if interested in getting more involved with SME's AM community initiatives, please let us know. And third and final, we will be recording this presentation and it will be available upon demand on the AM Technical Community Committee Leadership website. Thank you again for joining us, and I'll hand the microphone back to John.
Great, thank you for that. So we always welcome your questions throughout the session. Jennifer Coyne and I will be reviewing those and probably asking them as the time permits or it fits into the conversation. For now, I'll quickly introduce our panelists, and they can say a few words about what they do and how they came into additive manufacturing. So our moderator today will be Jennifer Coyne. She is also on the AM technical community with me and has a pretty good background in managing AM teams. And then, so Jen, why don't you go ahead and introduce yourself?
Hello, good afternoon. As John said, my name is Jen Coyne, and I've been in additive manufacturing for the past few years here, maybe 3 or so, and started with my AM journey at GE Transportation / Wabtec, and more recently joined the Barnes Global Advisors. And I'm glad to be here today talking to you about the various roles, because part of my job has been building out teams and enabling success with those various different disciplines with AM. So excited to dig into that today.
Great, and so Brett Hare is a design engineer for Wabtec, part of the AM global team.
Hi everyone, my name is Brett Hare. I lead the design team at Wabtec. On that team, we have a range of activities, from designing additive parts to training members of our organization to design their own additive parts. I've been in this role for about 3 years now, and prior to that, I've been in the transportation industry for about 8 years. I got started into additive through prototyping, and then prototypes became functional test parts, and then everything just kind of snowballed from there. So just kept digging further into additive, and good to be on the panel.
Great, welcome, Brett. And also in transportation and also a design engineer, we have Devin Anderson, except he makes very light things as opposed to Brett's very heavy things.
Yeah, all right. Hi, everybody. My name is Devin Anderson. I'm a systems engineer too at NASA Jet Propulsion Laboratory in the additive manufacturing group. So I primarily work on utilizing additive manufacturing technologies to enable engineers to lightweight or increase the structural integrity of hardware. Specifically, my research and my job role is to utilize topology optimization, additive manufacturing, latticing, field-driven simulation, like advanced engineering design, and get it into, space flight hardware design. So yeah, that's what I do.
Great, thanks, Devin. And lucky last is Evan Kirby, who's an applications engineer at Materialize, and also a former submariner.
Submariner is right, John. Thank you.
Okay.
It's interesting that you say that because my path to additive was long and torturous. Actually started in the Navy. I was on submarines and I was a nuclear technician. And my last duty station was actually instructing new sailors how to operate and maintain nuclear reactors. It has nothing to do with additive. I'm not an engineer by training, but just kind of by trade. And from there, I went to an ultra high pressure water jet company as an instructor. And again, I was teaching the customers of that company how to operate and maintain the water jet equipment, which then led me to Materialize, where I've been for the last 20 years, because they didn't have a training program for the Magic software, which is kind of the flagship software for data preparation for additive, and our flagship software. And I've been doing that ever since. And so what we do as application engineers is we touch Devin, we touch Brett, we touch Jennifer, and everything that they do, because so many people out there use our software to do that data prep.
Excellent. So we've got a very robust team, and Jen is going to be the lead moderator for today's activity. So with that, Jen, I'm going to turn it over to you to kick us off in earnest.
Yeah, great. Well, as you can see, we compiled a group of people that touch various aspects of the additive manufacturing supply chain. So today we're going to dive on the design and applications engineering spaces, and we're hoping probably at the next event, likely at Rapid Live, we'll dig into some of the other job competencies that were identified by SME and the volunteers that work on the advisory committee. So we really, the point of all of this is to show you guys what is available in additive manufacturing, and not necessarily that these are so different than any other engineering roles, but there's definitely new things about additive manufacturing and new skill sets and new tools that are required if you're going to work in the space. So we're going to dive into that and explore these two roles, and maybe also explore the differences between the two roles. So with that, I guess I will start it off with John's favorite question for the panelists here, which is how you found your way into AM. Did it find you? Did you try to run away from it? No, just kidding. But that sort of question, maybe elaborate on it a little bit. I know some of you talked about it in your intro, but elaborate a bit on how you found additive. So Evan, you already talked to us about, through the I'll call it like parallel skill set piece. Anything you want to add in addition to that?
Yeah, so it's like I said, what myself and my team do, we do pre and post sales support for our software products. And the application part comes in and helping Devin and Brett figure out how to use our software to get the parts that they need out of their machines. And so we're using our knowledge of our software, because they're very likely using it, and that's why they're calling us, to help them, again, get the best parts, or just get parts off the machine in the first place. So you don't have to be an engineer, but that initial training certainly helps.
Devin, you want to tell the group here how you found your way into AM?
Yeah, I'd have to say, well, to answer the question directly, AM found me. So I spent the first 3 years of my career working on the Mars 2020 sample return project, designing subtractively machined hardware for hermetically sealing Martian samples. So it was as far away from additive as you could imagine. I went to school for my master's and studied structural mechanics and accepted a different job offer at JPL, so I was promoted. The day I was promoted, my section manager took me from my job as in environmental testing straight down to the additive group. He said, "Hey, I want you to be down here. We need someone who understands structural mechanics, simulation, and optimization." And my mind was kind of blown. I was like, I I was given a job, and the first day I start, they just pulled me on to something completely different. And it actually worked out perfectly fine. I mean, I picked after I learned the fundamentals like overhangs, design for additive manufacturing. It turns out my skill set was actually perfect for the job. So I'm really glad it found me.
Sounds like that supervisor knew what they were doing.
Yeah. Yep, I think so too.
Brett, what do you think?
Yeah, so like I said, I started needing some prototypes. We were designing a new fan, and we wanted to 3D print it, and we ended up being able to take a pretty large fan up to 4,000 RPM for testing, and got a bunch of data there, and that kind of just sparked my interest in it. And then I went down the road that everyone kind of follows, which is taking a conventional part and seeing if you can 3D printing it, and then eventually designing parts that are optimized for 3D printing. And as I was on that journey, a role opened up at WabTech in the additive team. So that's been, from there, it's just been, full additive optimization type work.
And John, I know you're a fellow moderator, but anything to add for you from your journey?
Well, yeah, I mean, I've been in it a long time, I guess back in the late 90s and at least metal additive, which was, still being spun out of national labs at that point. So, of course, my joke is I was the least valuable engineer at Honeywell at the time, so they could put me on this project, which was clearly going nowhere. Fortunately, they did. And really, though, by the time I got to Lockheed, where I spent most of my career, we were using and I guess I've been fortunate to use pretty much all of the different forms or categories of additive, trying to make something, because the work at Lockheed, especially at Skunk Works, is typically making something that nobody's made before for a purpose that you don't understand or can't possibly know. So, it's always very interesting. Certainly can't talk about it, which makes additive perfect for it. And I think, what I would share similarly, and I think what we sort of oversimplify, which is, it doesn't change the role of the engineer, it just adds to the skill set for the engineer. It seems like that's echoed in Brett and Devin's experience, and Evan, I know just from, in prior conversations with you, you talk to a wide variety of engineers, just walking them through like, you do what you normally do, but just do this a little bit different. You're kind of there.
Yeah, no, I agree. And that's, I think, pretty clear, and maybe a message that we're hoping to share here is there's certainly some unique skill sets that help you in the AM field, but there's certainly, it's not like you have to have an additive manufacturing degree. In fact, there's not that many of them yet to be in this field. And so we'll get into that maybe a bit later with degrees and what got you there. But before we go there, I do want to draw this distinction between design engineering and applications engineering. So we're going to label Evan as an applications engineer, and we're going to label Evan and Brett in the design engineering space, just for drawing a distinction. Obviously, I'm sure that at least I know, Brett and Devin, you probably venture over into the application space too, but just so we can draw that distinction, we'll call them as such today. So starting with the design engineers, can you just give me like a day in the life? Like what does a design engineer of additively manufactured parts or in an AM team do? Maybe Brett, you want to start?
Sure. So like John said, it's an added skill onto your typical breadth of engineering. So in a day in a life, you're running projects, you're designing parts, you're doing analysis, and all of that. As most of my career has been in conventional manufacturing, it's very similar to what you're doing day to day. You're just taking everything that one extra step to design it for additive manufacturing, which involves a lot more computer simulation, or you can involve a lot more computer simulation, I should say. As far as you could do a build simulation, topology, optimization. And really, you can detail parts to a much finer level than you can, say, like with a welding or a casting. So it's very intensive on 3D modeling and analysis from my day-to-day side, along with the regular project engineering type work.
Gotcha. Devin, what are your thoughts there?
Yeah, I mean, I feel like Brett kind of said most of what I was going to say, but the way that I would word it is essentially a design engineer utilizes a disruptive, innovative manufacturing technology to enable engineers to design otherwise impossible geometries to manufacture. So you decrease schedule, you decrease cost, you increase structural integrity. You take into consideration the fundamentals of additive manufacturing, whether it's like laser powder bed fusion, directed energy deposition, things like that, and you look into part consolidation. So it's really using your imagination to create a much better design that's just better for everybody's schedule, performance, cost, weight. But yeah, like Brett said, it's a lot of simulation and things like that.
Yeah, so you got this great tool set. Go ahead, John. Sorry.
Yeah, I was just going to pick up on you because you talked a lot of your first job was kind of in structural analysis. So I gather that kind of gives you, the structural got people, sort of have X-ray vision into structures, kind of like, they're constantly looking what the load path is going to be, what the failure points are. So I suspect that kind of gives you, you have the design component, but then you're constantly assessing, like, how can I make the structure more efficient?
Yeah, that's essentially it. So, I mean, you'll run like an initial FEA, you'll see your load paths, deflection, where you are in regards to your performance requirements, structural integrity. And then from there, with additive manufacturing, I mean, you don't really have to worry about throwing it on a 5-axis CNC or anything. You just make sure that you hit the fundamentals of overhang, surface roughness, things along those lines, your build limitations. And yeah, it really gives you a lot of freedom for I would say optimal hardware.
Cool. So Evan, on the flip side here, let's dive into what does it mean to be an applications engineer? Like, what's the day in the life of someone who's working more on the application side and maybe less on the, I'll say, like design freedom side?
Yeah, thanks, Jen. It basically, what we wind up doing is helping all of our customers figure out how they need to use the software, again, to get their most desirable part. I haven't talked to Devin. I think I've talked with Brett in the past, but I know that I've emailed people at both of their facilities and talked with them as well. And typically, they're going to have questions on how our software is going to help them get those parts out the door. And so, like Devin said, looking at overhangs, they might call and ask, what kind of support is going to be best to use on an overhang of this type, or maybe we can discuss support strategies for other areas, that type of thing. And then of course we touch, and it's something that John said, we touch basically all industries and all additive technologies. And so not only do you have to talk to people about metal, but you have to talk to people about laser sintering and multi-jet fusion, stereolithography. So we're really kind of jack of all trades, and we have a fair bit of knowledge about all the different technologies and what's required to make it so that people can get good parts off of those. But we don't have the in-depth knowledge that Devin or Brett have either about a specific technology that they're using for their application. But that's kind of how it goes, answering questions and giving people support and helping them figure out how to get their stuff done.
And I have a question for John. I know I'm like taking this leadership thing seriously. Now I'm going to pick on you too. As they're talking, I'm reflecting a bit on, maybe the difference between something you talk about, which is like this DFAM versus MFAM, and how an applications engineer may sit on one side and a design engineer may sit on the other. Do you mind taking a few minutes and framing that for people here?
Yeah, so I identify more with applications engineers myself. I mean, I'm a materials engineer, so I'm rubbish at designing anything, but I can think it, I can visualize it, I just can't do anything with it. So I think the application side, the way I kind of dissect it is, one is more like the requirements of the part. It lives in an environment, it needs to be made, and the design engineer is more structural in a sense. So they're looking after what's physically possible using physics, and most of the places that I've worked, we kind of kept those things distinct and separate, so that one owned the the requirement side, and the other one said we can either meet those requirements or we can't. So that's always kind of the way that I kind of dice up the world. And there's plenty of amateur applications engineers and amateur design engineers out there like myself who like to tinker. But I think it's a team sport. Most of manufacturing actually is. Additive is certainly no different, perhaps even more so. So that's kind of how I view it. And a little bit, you asked about the MFAM and DFAM. So, well, we at TBGA kind of divide the world up into modified for additive versus design for additive. And within that, all design for additive includes some modified for additive. So you do certain things to make sure that it survives the print or the build. And then most people right now, I think, have a view on the DFAM side of these highly latticed structures that are bionic and look like they're inspired by nature. It can be very, very difficult to actually print successfully or remove support structures and those types of things. So that's where the MFAM comes in. And so production engineers always talk about MFAM. Design engineers always talk about DFAM. So, I think it's a recognition that you need both. And really there's nothing different about that world than legacy manufacturing. So that's the other thing I talk about with some of my peers, which is additive needs to learn a lot more about legacy manufacturing, and legacy manufacturing needs to embrace additive manufacturing more.
Yeah, I think it's great when we have examples like we have on the panel today that have come from other backgrounds. They're not just starting with AM, but they're starting with a rich experience in traditional manufacturing. And I guess
Sorry, Jen. I mean, I think that's actually a good point. So when you think about the applications, both in spaceflight, where it's the usual statement, failure is not an option, but it really isn't. It's a conservative environment. And especially when you're taking samples, back from Mars, you're investing a lot of time and effort in doing that. So, a simple failure isn't going to work. And on the flip side, we've got, who would have thought that, I guess I wouldn't have naturally suspected that rail, would be an industry that's, heavily into additive, but, it's the idea of thinking about what's possible now that you can do it. And, lightweighting isn't probably always a deal, but improving efficiency because of heat exchangers or, the electric motors or whatever they happen to be, I think that's where I just view it as like, that's additive just enables engineers to do their job better. That's make lightweight structures, make efficient structures, hit the requirements. So I don't know, that's one of the things that I'm sort of, as much as my daughters, abhor the idea of being an engineer because I'm one, I like to pass on to other engineers that, we're here to solve problems. That's pretty much first and foremost.
Yeah, absolutely. And I'll circle back to that DFAM versus MFAM thing for just 1 second, because I guess as I think about applications engineering, I think about maybe it's a subset, but I think about the people that maybe work at, for example, a service bureau, and their job is to take in a pre-designed part that, say, Devin or Brett had designed and make sure that it is modified correctly for AM using, Materialize or whatever software package that is available to them. And that's like that that last check, they're in there, they're working with customers, they're making sure that the thing prints well because, you know, that's a big deal.
Failure's not an option.
Yeah, failure's not an option. It's expensive to fail. And well, certainly on the build, and it's worse than that, you know, beyond the build, right? Failure. But and then I think of the design engineers as the one like prepping that, and they live in like the opportunistic area of DFAM, so they don't have to necessarily think initially about supports and initially about build, though hopefully that's always in the back of their mind. But they get to live in a little bit more of like a design freedom world versus I need supports here, here, and here, and this is how I'm going to net immediately.
Yeah, and I can pick on Devin here just because, you know, we do some work with JPL, and so, you know, Mike at JPL would yell at me if I didn't bring up, you know, his big thing is get in at the concept stage, you know, and it isn't not so much about making a bionic shape, but part consolidation is a big deal, and that's where you get the weight saving. But if you wait till all the other good options have been exhausted, you know, now you're just throwing a hammer.
Did you have that pun on purpose? If you wait.
No. Wow, that's how good I am now, John. I don't even, you know, I have dad jokes coming out that I'd even, just automatic.
All right. Okay, so I had maybe a different line of questioning here for the groups here. Hopefully we now kind of understand the differences. So sounds like most of us, you know, started our careers outside of AM. What do you think it has been your biggest challenge in adapting your skill set? And what do you think was maybe pretty easy in adapting your skill set? Like it just a skill that easily transported over into this new AM world. I'll start with you, Evan, because you're highlighted on my screen there.
Yeah, so as I kind of noted, my skill set really didn't have anything to do with additive. What I did have was the ability to communicate knowledge that I had to other people, and that's how I got my start at Materialize. And then went from there, and it's just kind of 20 years of osmosis and seeing these various data sets for 20 years and being able to then look at them and say, well, yeah, no, I don't think that's going to work. Maybe we should try it this way. So I didn't really have a specific skill set for additive itself, but you know, with enough experience in a certain topic, you can get there. So it's kind of an interesting question for me.
Oh, that's fine too. I think for you, it's pretty obvious, right? Like you had that training skill set, which transferred into what you were trying to do. Yeah. What about you, Devin?
Okay, so yeah, this one's actually pretty interesting. I think when I first got into additive manufacturing, I already had 3 years of experience with spaceflight hardware design, purely subtractive designs. So when I began to understand the fundamentals of additive manufacturing, like overhangs and things like that, surface roughness, I kind of just would look at engineering problems all across the lab and say, hey, additive's the solution. We'll decrease your mass, we'll increase your structural integrity, we'll do this, we'll do that. But you kind of have to pick the problems that you want to tackle, because say you're working on like some optical system and you have to print flexures, you might have to touch it up with wire EDM. Like it's very rare that you print something and you can just slap it on your test bed or onto your spacecraft. There's always going to be surface post processing, subtractive machining after the print, like threading, things like that, surfacing. So my issue was I was too gung-ho and happy to just solve everything with additive, because JPL, it's spaceflight hardware design, so a lot of the components can fit in a printer. You think you find a printer, it has your material, it has your A-basis material properties, you just run with it, that's the solution. Then you check the cost and you're like, oh my God, we shouldn't do this. But so that was my biggest challenge, was just picking applications that seemed most fitting, where additive really makes a difference. So skills that transferred over, I would say hardware design, and then also my understanding of structural mechanics. I think those, it was not much of a difference at all. Finite element analysis does not change. If you have an organic looking structure or a lattice structure, you just follow the fundamentals, understand how it works, and it's great. So those were two assets that I brought to my group, and yeah, not much changed other than figuring out how to use the new tools.
Yeah, that makes sense a lot, especially like it's physics-based stuff for the most part. It's not changing the new manufacturing process. So yeah, that makes sense. Brett, what do you think? Your biggest challenge and what was the same?
I think everybody that gets into additive design has the same problem that Devin did, and everyone is overly optimistic, especially as a young engineer. So that's definitely a struggle. I think from my side, being in transit or in transportation, we and WabTech jumped into additive before a lot of other companies in the same business area did. And at the time when we started to jump in, all of the materials and machines were sort of geared towards the aerospace industry and other industries that were original drivers of additive. So there was quite a bit of challenge finding materials and machine parameters that we could use to make our parts. And we've come a long way over the last couple of years, but still that's a challenge to take a very limited selection of materials that you have, not very limited, but a limited selection of materials you have for additive and using those for freight or other industries that are not as cost sensitive. And then skill sets that carried over. So prior to additive manufacturing, most of my components that I designed were castings. So within the casting world, you have a little bit of freedom to make organic shapes or a part that looks exactly how you want it and the shapes that you want it to be. So my background with modeling, those castings carried over well. And then, like Devin, I also have a structural background. So like everything he said, from an FEA standpoint, it's the same. And then just visualizing a part and how it's tied down onto the build plate, while also using a support simulation software and designing the part so that it's not going to fail during build, is helpful to have a structural background or structural mindset there to support the part.
You know, it's funny, Brett, you and both, Devin both, and John actually touched on it as well. One of the things that we wind up doing is when we get the young gung-ho engineer, and they send us a part and we say, we want to build this additively, and we'll say, why? Why do you want to do that? And then when we start talking like Devin, talking about cost, they'll go, oh, yeah, no, that's not really what you want to do with this. And so frequently we will take and figure out a solution somehow, but also make sure that they're not trying to do something that just doesn't make sense.
Yeah, it's a lesson that I think most of us learned the hard way when we got into AM. Yeah. But that does bring me maybe to a point on the application side, Evan. So you get the opportunity as an applications engineer or within that space to work with a lot of different customers. Can you talk about like some of the exciting things or maybe the challenging parts of working so closely with customers? Think about it from maybe someone in the audience who's like, not quite sure that I like to work with customers. Give some highlights, some lowlights.
So, yeah, some of the exciting things, it's every day is different. Every day is the same, but every day is different. Every day is the same because the questions that we get are frequently questions that we've had in the past. but every day is different because you're talking to someone from JPL, you're talking to someone from Wabtec, you're talking to someone from General Motors, Ford. One of my favorite games I like to play with people that are just getting into additive is I'll ask them, name an industry where you would never think you would find additive. And I would be willing to bet that I can name a company that uses additive, and myself, since I've been doing this for 20 years, I can probably name a person at that company that uses additive. And I have not been stumped yet. So it's a really fun game, and it's challenging because it's always different, but it's always the same. So you have to maintain your focus because it's always the same, but at the same time, you're always being challenged by people that are coming from different backgrounds and doing different things and trying to achieve different things.
John, can you try him? Try an industry. You got one for him? If not, I have one.
Ice cream.
Ice cream. Well, so what I do is I'll broaden that into the food industry, right? So Coca-Cola.
Coca-Cola, yeah. We actually work with a company that's making a new ice cream machine. So they're not the traditional way of doing it, but and there was actually a really interesting story. I like this story. It was a bread, I'm going to say a bread manufacturer, a baker, an industrial baker. So they make industrial ovens making bread. And they determined a way to make they literally found a better way to slice bread. They designed the knife to have like cooling holes in it so that when they cut the bread as it's the right temperature, the blade maintains the temperature, and it's, it just works out. But I asked somebody like, how did you get started in that? And they just said, well, we just have a CEO that's really curious. And he's like, surely there must be a better way that we could do this if we did it. And, it was what I love. It's solved a problem. You got to know what your problems are. You go out and find solutions to it.
I like that.
Didn't think I could do it, did you?
That's nice. Now we just got to.
Yeah, right. Or a spice rack. I might jump in. There's a question here which I think is good, and I'm going to ask Jen, you first, because you were in a former, you're in a managerial role now, but you previously were also. How would you communicate your AM areas of expertise to employers who may not be as familiar with the field and know the differences between the different AM technologies? Like, how do you start that conversation?
Yeah.
Bring playing cards. I got 3 of a kind. 2 powder bed fusion. 7
modalities, and I'm super good at 4 of them. No, I don't know. So I think the way you talked about it depends on who you're talking to. I'm not giving interviewing advice here. That might not be a good thing, but it depends on who you're talking to. Because some people, I think the thing that you mentioned, like we're solving problems and it's another tool set for solving problems. That's probably the easiest way to talk about AM. It's a new way to solve problems. And honestly, like if you're trying to bring in your expertise to start AM at a company, you think about how to address their problems with these technologies, and maybe the details are less important about which ones. And but we all know that there's a lot going on in the AM world, and there's so many options for addressing these problems. And that's why I think like events like this are important, because you do have to stay current. You do have to understand the industry and what's available out there, and keep your skill set, pretty current. Well, I already said that word, but just up to date, because something new is going to happen, and it may just be the thing that you need to solve that problem that you're looking for. But I think in general, there's a lot of companies that understand their strategy of AM, and then there's some that maybe even in your current role, you could introduce an AM strategy. And I think it's important then to talk about the why AM for our business, and not necessarily get lost in the weeds of 7 modalities and why they are different or the same. I don't know.
More importantly, why?
Yeah.
Why were you using all those different modes?
Yeah.
I guess,
And
sorry,
go ahead.
just related to that, the same question was, how do you politely ask in an interview, what are you using? I guess that's kind of the usual, perhaps engineer question, but what kind of machines do you have?
Yeah.
Brett, do you get these kinds of questions within, young guns trying to come in and work their way into your group?
Yeah. So for the first question of the modalities, I think the best way to communicate is to show examples of what each modality can do, and examples of parts that were produced for each, and as you show people more examples and ways that people have solved problems, then sometimes you'll see someone will say, "Ah, we have that same problem, and we don't know how to solve it," and additive can be the solution there. And then the modality can change, of course, but I think to just show as many examples as possible is one way to do it. And yeah, we have a lot of people looking at our different modalities and machines. It's really company dependent. So it's tough to really give a blanket answer of what modalities to go after first.
Have like really difficult interview questions like fiber rake or silicone rake, which is better? Go.
Yeah, I could see us trying both.
Devin, what about you? And within your group, I would assume is very sought after to come into the additive group at JPL. How do you have conversations with people that either want in or you're trying to recruit into the group?
I feel like I get messages about at least like one a week from somebody around the world asking questions about JPL additive manufacturing. It's kind of hard to say. I mean, I'll pretty much schedule a meeting. We'll talk for about an hour about what we do at JPL with additive manufacturing, the technologies that we use, what we're trying to advance in the direction that we're going. And if it turns out that they have a great background, they're really interested, they're a stellar candidate, then I would actually refer them to my group supervisor or somebody within my section so that we could bring them in. But yeah, it's typically graduate students, PhDs or master's students who've done a bunch of research in additive manufacturing, understand the technologies, and we try to bring in people who already have developed a great skill set versus training new hires, just because it takes a lot of time and that's a lot of cost.
There's another question about MBAs. How valuable or necessary would an MBA be if you want to advance your career in a less technical, more administrative way? I'll throw that at you, John. Just, I think a little.
Yeah.
Not to say you're less technical, but.
Wow. Okay.
Maybe the day-to-day might be less so than theirs.
Yeah. So I think the vision for using additive has held the industry back. A lot of times it's engineers pushing something up. And in the few instances where I've seen CEOs pushing it down, that has rarely met with any sort of good outcome. You have to have buy-in across the company. And I read an article recently, which I'm not sure I 100% agree with, that they said basically if you really want to get the most out of additive, the CEO has to buy in. Part of me says I don't want that to be true. Does it a whole lot easier if the CEO buys in? Yes, because it means structurally you can facilitate the disruption. And I think that's another key point. Additive is disruptive. As much as we want to shove it into a box with other manufacturing techniques, it does want to challenge the way you design things and do your structural analysis, et cetera. So it's not as easy as just handing somebody a new pen and saying, use this pen instead of the previous mechanical pencil. So I think that, when we deal with companies, you know, we talk strategy, we talk structure, we talk people, we talk training. All of those things are important because you've got to reduce the friction inside the organization, and that's typically what, you know, MBAs are taught to do. Now, I suspect Evan, you know, you probably have some experience here because you probably end up talking to a variety of different people. Well, certainly over 20 years, you people that you probably talked to 20 years ago have progressed, I'm hoping.
Certainly. You know, it's interesting, Devin. You're talking about people with advanced degrees, and you want a bunch of experience already. I'm kind of the exact opposite of that. For us, it's really the newbie that we're looking for, because someone that's working for me, even though that we can train them our software, and then they get that experience as they go along. And then, yeah, I've had some of my people go on, John, as well. Right now, they haven't gone as far as advanced as maybe like you have in terms of going outside of the technical realm. But I think you're right. I think that vision to see where additive can be applied and how to make it happen, and that's really what's important for that. And any tool that you can have that helps you do that, and if it helps with reducing friction within the organization, that's great. So yeah, kind of like that.
I think that's we've kind of focused here a little bit on design and applications engineers, but really what we're talking about is adding skills onto existing skills, and that's certainly applicable to, you know, the business environment. We're not talking about relearning your MBA. We're simply understanding, knowing what you know about accounting or marketing. How does this apply to that?
I think I've been more involved with the financial side of the business than I was previously in the additive group. I think every company, as they start to design some additive parts, you quickly realize that you want to buy some additive machines, and then you have to start putting a business case together and justifying cost. So it's definitely more of a point on additive manufacturing than I think other conventional engineering disciplines.
And probably slightly easier because there's not, you know, you'd have a hard time making a business case to buy a forge press. But back when forging was new, it was pretty easy. So this actually affords an opportunity because not a lot of people even have the skills to, you know, talk about getting the right machine.
Definitely.
Yeah, I think, Brett, your point is solid, right? That anyone, even like, you know, you go through training on additive manufacturing where you do your first additive project, odds are pretty good you're going to run a business case analysis. Don't necessarily always, that's not like a required step in the design engineering process, but it is in additive manufacturing. So I think that's a pretty valid point that you bring up, that you will start to speak ROI, you'll start to understand, you know, what makes a broader business case, not even just a cost model, but a broader business case when you dig into AM. So it's pretty good. It'll push you beyond your typical design engineering skill set that you're going to learn in college. Speaking of what you learn in college, can you just tell the audience like what your background, you know, we've got a pretty varied background, I think, here. We already talked a lot about skill sets, but just as far as like if you are looking at degrees, what types of degrees do you have, or maybe some people in your team that do your job? Or trainings or industry experience, Devin. I know you mentioned that's cool too. So we're showing a very wide variety here. So, Devin, you want to start?
Yeah. So, I mean, for myself, I have a Bachelor of Science in Mechanical Engineering and a Master of Science in Mechanical Engineering with an emphasis in structural mechanics. But from what I've seen in industry, like my friends who are all over the place, I mean, whether it's like defense or it's like in topology somewhere else, You don't exactly need to have a graduate degree. It's great to have if you want to go into the research side of things, or you really want to do like advanced simulation and design. Sure, master's is great, but I think the bare minimum should just be maybe material science, mechanical, aerospace, or even a civil engineering bachelor's. If you had any of those degrees, I think you could get your foot in the door and you could do some great things with additive. If you study specifically like a master's degree in additive manufacturing, you're just that much further ahead the second that you go into industry. But you can learn a lot on the job without having an additive specific degree. But bachelor's minimum, graduate degree if you want to do research and some super crazy things.
Makes sense for especially that line of work. Brett, what's your background as far as degrees go?
Yeah, pretty similar to what Devin said. Most of our team is mechanical engineers, and then a lot of people either have a certificate or a master's in additive, but it's definitely not required. It seems like with everything being new now, people are more getting into the industry and then getting the master's degree after they've gone into that industry. So really, just the Bachelor of Science is what's really required.
And Evan, I'm curious, what about some of your colleagues? Are they software folks, or what about that side as well?
So yeah, it's interesting that you say that, because our title leads people to think that we all develop software, and that's kind of misleading, because what we deal with is helping people figure out how to use additive, right? And so, with the exception of myself, everyone's a mechanical engineer of some type, whether it be a bachelor's or a master's. Myself, my degree is in radiation protection technology, so it has nothing to do with anything about additive. For me, a lot of it is what do you want to do, right? It's like Devin said. If you want to do research, that type of thing, an advanced degree, great. If you want to get your hands dirty and go operate a machine, heck, you don't even need a degree, right? Yep. You can, being technically inclined and being a machine operator, some type of that type of knowledge will really help you in that instance. So for us, for my team specifically, mechanical engineering or design engineering is really what we're kind of looking for, again, so we can help our customers.
That makes a lot of sense, and I think that's a great point, that there's also these other fields which we're maybe not focusing on today, but the technicians and operators, there's so many options in AM, and that's really why we wanted to break out this panel the way we're doing it, because we want to highlight those options so that we reach this broad group with what works for you if you want to be a part of this industry. So with just 5 minutes left, I wanted to go around here and say, just ask what's your favorite part of your job, and then what advice you might have for someone that would want to enter into the AM space. So I'll start. John, you're gonna close this off, so you get to go last. But Brett, you want to start?
Sure. I'll kind of roll both into one answer. My favorite part of the job is it's a very new industry, and so everything that you're working on and doing is very new globally, and there's a lot of chances there's a good chance that nobody's done this before. So any questions you have during the design process or manufacturing process, you're probably going to have to make a design of experiments or something along those lines to find your answers. And I really like to go through that thought process of designing and then learning something new and then reapplying it, and that process is really fun for me, and it keeps everything fresh and interesting day to day. So for advice for a career in additive is you have to have a mentality where you're not going to look at a textbook and find your answer for everything. You really have to take a lot of initiative, to go after understanding what the problems are that you're facing, doing testing, getting hands-on, getting to know your mechanical or your manufacturing engineering group, and working with them to solve problems, and just taking a lot of initiative to push the technology forward, because that's what we're all doing here.
What do you think, Devin?
Okay, so just to make sure I understand this correctly, it's my favorite part of the job, and then advice for getting into the field.
Yeah, you got it.
Okay, so my favorite part about the job is utilizing the latest manufacturing technology and simulation/design software to essentially design things that are just non-intuitive, that are just incredibly complex and super cool. So like an example would be a homogenized lattice topology optimization, where you vary the thickness as a function of a stress field, like a von Mises stress or displacement field. So you lightweight things, it's just, it's so cool, it's crazy. It's pretty interesting research. You get to validate it, you get to test it, you get to see it in use. And it's something that I could have never solved with my hands. It's just incredible. So diving into the latest research, staying on top of that, and putting it into effect is probably my favorite part of the job. And then regarding advice that I would have for this particular field in additive manufacturing, it's kind of hard to say what you should do or how you should do it. I mean, there's a million different things you could be doing. You could jump into research, you could be a tech, and you could be operating machines and removing support material and delivering hardware. You could be just a design engineer who's setting up your build your build plates, the processes, parameters, whatever. So it's a pretty crazy field. There's so much that you can do. My step would be to network, try to get your foot in the door, and I think the specific area in additive manufacturing is going to find you. You'll find out what interests you, you'll find out what you're good at, and I guess what you're most valuable at, so you could be an asset for a team and you focus there. So getting your foot in the door is the first step.
Evan, what do you have for us?
So my favorite part of the job, and it's something that Devin just touched on, is the fact that really still additive is a relatively small community, and it's pretty easy to network. And not only is it small, but it's also very friendly still. And when you go to Rapid or AMUG, then what you find out is people are willing to share their knowledge with you. So you could come talk to me. You might find Devin at Rapid or AMUG and Brett there as well, along with John or Jen. And then you just talk and you build those relationships. And for me, it's talking to all these different people and seeing what they're doing. Like I said before, I've seen just about everything, just about diapers, for God's sake, I've seen as come to me as files. So it's just, that's kind of strange, but that it has happened. And when you see that, and you see, again, something that Devin said, there's many, many different opportunities to get involved in additive. And it's just find that one that you think is going to fit you best, and it very well could find you as well. So if you really want to get into additive, it's out there. It's not too hard to find because almost everyone's doing it now. But use those social media links to go do it.
Even diapers. Brett and I need
diapers.
We need that.
Yeah. Yep. Seen them.
That's funny. All right, John, what's your advice and maybe some closing remarks?
Yeah, I think my advice is get involved. I think to Evan's point, the community is I think very open. It's also very international, and so it's a very easy place to get in, maneuver, and get opinions. You know, I would say with the advent of the internet, everybody's also an expert, so you do have to check your references. probably go through that process and vet the answers that you're getting. There's ways to get training now. There's courses to take online. Information's easy to get, in 2021. So I think that the challenge that I would throw out to people who are interested in it is really not so much just following the herd, and it's about solving problems. And there's a lot of industries using additive that nobody even talks about. So that's the good news. We don't talk about the first ever something or other that was 3D printed. It's become commonplace. All launch vehicles at this point are reliant on additive manufacturing, spaceflight, and so there's any number, and it's not just aerospace anymore. We're talking about rail and transit applications now. We're talking about baking applications. So I don't think it's a reflection of anything other than having enough awareness to go solve what is largely an infinite problem. And there's a lot of things that are out there, and we've been casting things for centuries, and we're still figuring out better ways of casting things. So I think that it's easy to beat up on additive a little bit because it's a young industry, but the reality is, if I came down from Mars and you could show me in situ monitored part where I could collect real-time inspection data and collect all this information, and I'd know all this stuff by the conclusion of the build, and then you went and showed me, kind of a forged part or a machine part where I have no data on that part, I would ask you why you're still doing the other thing. So, the path is clear if you want to know a lot about the part. So I think it's a great community, and I think that it's only got one way to go, which is up, and it's only going to get more diverse, both in terms of technologies, but also people. And I think that's the number one reason why it's where it's at, is not enough people understand it, not enough people are aware of it. As soon as they gravitate around one additive technology, they tend to get stuck there. That doesn't solve all the time. So we need a lot of Evans who can communicate and articulate points to a lot of people. So those are my 2 cents.
Great. Okay, then I just want to say thank you to the panelists, co-moderator John, and to SME for helping us host this. It's been a pleasure to dive into applications versus design and just bring a little more color and light to the world of additive manufacturing and careers in it. So thank you all for your time today.
Thank you.